Hi, my name is Amira, and this is, I don't know how to say their names, but it's the researchers 2011 study of episodic memory. So what is this research about? Today we're going to learn about does the brain activity during encoding predict whether a memory is successfully formed? And this matters because it can help us identify mechanisms of memory formation, especially in education, aging, or even clinical disorders. Was to help us understand the success or even failure in encoding human episodic memory. In this study, they consist of 66 male participants, and the ages range from the youngest 3 and the oldest to almost 28. And the stimuli that was used was movie clips, and these were chosen because it requires encoding and remembering the clip into your short-term memory, and then later recalling the episodic event in your long-term memory, which revealing whether it was successful in coding or not, and then later showing what factors contribute to that. The method that was used was the functional MRI, and this was seen during each presentation of the stimulus. Like as you can see to your right, this is the presentation of the stimulus during encoding, and the several seconds following determining if it was remembered or not. The cognitive process is basically reflecting the coding process as you rehearse and try to recall the pairs of the movie clips and encoding it from your short-term to your long-term memory. So today we're going to be talking about the method, and during this experiment there were during the study there were 3 experiments, but we're only going to focus on 1 and 3. And there were 2 stages for each experiment. As I previously said, there were 6 male participants, and each experiment had 2 stages, 1 the study phase and 2 the recall test phase. And the study phase is where participants will review the movie clips, 1 stimulus pair at a time. And then stage 2 would be the test and recall phase, where after a delay the memory will be tested. The study phase took place in the fMRI scanner, while the test phase took outside the scanner. And what will happen is the participant would basically study the movie clip, and there will be like a random blank delay or like a blank interval, and then they'll be tested on what they remember. And the blank intervals will range from 4 to 10 seconds. They're really random. And the open-ended questions the participants after that would be asked open-ended questions, and then they have to rate how confident they were in their answer. And basically, these blank intervals were really random because they actually help prevent prediction of the next event. And they help avoid anticipation and related brain signals. So, we humans pick up on patterns really quickly, and we know how to overcome them. So, if the blank intervals were all the same length, then participants would predict the timing, which wouldn't showcase pure encoding processes, and would just show strategy. The control stimuli was the non-memory control task, and this was needed because the memory task, which is remembering the movie clips, the memory task needed to be compared with a non-memory task, because if you have to compare a memory task with a memory task, it's you won't get the best accurate results because it's the same. So you need to compare it with something different. So, experiment 1, here are the results. And as you can see, the brain region highlighted in the left figure are most likely the hippocampus. And these are highlighted because it's due to the subtraction method in the fMRI, which is when the scientists do the remember minus what's forgotten. That's how they get the scaling of what to measure. And then the color scale, as you got to see from the yellow and the orange, the brighter it is, shows the more confident the participant is in answering the open-ended questions, and most likely what they more remembering. And the less lighter the color is, the less bright it is, the less confident, unsure, and most likely they didn't really remember. So the graphs on the right, these are bullet time courses that show present. These are bullet time courses that show present. Sorry about that. These are bullet time courses that show present signal change over time. The curves represent the conditions, which are remembered versus forgotten in different colors. The remembered is solid while the forgotten is fast. For the axis, the x-axis represents time while the y-axis represents percentage of signal change. The vertical dashed lines mark other event that has come up in the memory of the participant's mind after a blank delay. The effect of this shows that remembered trials show a higher, bold, or confident response than the forgotten. So the main takeaway of this is the brain activity, particularly the hippocampus, as you can see right here, is during encoding it predicts memory success, which is they're getting close to the researchers' question answering and supporting it. So experiment 3, as previously shown in experiment 1, it's the same thing. It's the hippocampus. And the line plots are kind of similar to experiment 1, but however, experiment 3 includes a new condition. It's focused on something else, a new manipulation variable. So the color occurs in experiment 3. It's important because it shows how the hippocampus activity reflects anticipation and not encoding. So this change was needed because it shows that the subsequent This change was needed because it shows that the subsequent memory effect, which is where the brain activity during the coding, showing that it's predicting later memory performance. This memory effect isn't due to expectation but tied directly to encoding. It rules out the blank period activity, like when the blank intervals show up, is simply anticipation of upcoming event. So it rules out that that blank period activity is not simply because of anticipation of upcoming event. And it shows that the effect, it demonstrates that the encoding success signal holds even when the timing is unpredictable. So this doesn't mean the encoding stops once they show the blank delay. No, it's holds overall, or even when memory is difficulty vary. So the main takeaway of this is that it actually confirms that the initial finding of the hippocampus activity during encoding drives memory formation. So here's our conclusion. We have the papers keep fighting and the news of memory formation. The papers keep finding is that the activity in the hippocampus during stimulus encoding predicts whether the item will be remembered or not. So basically, actually I'm gonna say that part later. And then what it tells about memory formation is that successful memory formation depends critically on early encoding processes in the hippocampus, which supports the answer to the researcher's question, and it offers us assistance for encoding strength, which can be applied to educational, clinical, and cognitive neuroscience research. And basically this is saying that the brain activity, this study supports the research question that brain activity, wherever we see it, and when we do research during encoding, does predict whether memory is successfully formed or not. As you can see in the functional MRI, that the brain activity there, showing that color scale, how high is, how low it is, the brain activity, and then figuring out what's being encoded, that it does predict whether that memory will be formed or not. Thank you so much.